Okay, here's another question for us to try. We've got a car accelerating from 10 meters per second up to 40 meters per second, and it takes 28 seconds to do that. And we are required to find the acceleration and the displacement. So, first thing I do is simply divide my page into two. In the first half, I write what I know from the question, and you can highlight it or simply write it down. I prefer to write it down. So, U, V, A, S, T, these are the standard variables that you would usually think about. U is initial speed, which is 10 meters per second. The final speed is 40 meters per second. Acceleration is what we are required to find. S we are also required to find, and T is the 28 seconds. So before we can proceed, we need to remind ourselves of the different equations that we have to use. We get V equals U plus AT. There's S equals UT plus a half AT squared. And we have V squared equals U squared plus 2AS. So we want an equation that's got A but doesn't have S in it, and that top one there is going to fit the bill. So V equals U plus AT should allow us to get the acceleration. Now we can rearrange it now or we can rearrange it later, doesn't really matter. I'm just going to put the numbers in. So V is 40, the initial speed was 10, the acceleration we don't know, and the time is 28. So to solve this we need to get rid of 10, so that's going to subtract from both sides, so that becomes 40 take away 10, that's 30 equals 28A. So A equals 30 divided by 28. And we can put that into a calculator, so 30 divided by 28 gives us that. This gives us 1.07. Round it to that, let's be fine, 1.07 units meters per second squared. So this has now got this information here, 1.07 meters per second squared, and we are required to find S, so why not use this equation here. So for the second part, we'll use S equals UT plus a half AT squared. So U is 10, T is 28, the acceleration is 1.07 times 28, that's squared. So now we use a calculator again. Let's clear that. So it's 10 times 28 plus 0.5 times 1.07 times 28 squared. And that equals that lot, which is 699.44. Let's put 699.44. Now, number of significant figures is what you need to bear in mind here. In the question, the information I gave you is 2 significant figures, so this should also be rounded to 2 significant figures. So in reality, we should round this to 700 meters, where the first 2 are significant.